Good morning. My name is Brandon Martinez. I am a student of the chemical engineering career at the Autonomous University of Zacatecas. And today I will present my poster entitled Effect of the Substrate in Temperature Variation on the Physical Properties in the Manganese Sulfide Thin Films Synthesized by the SILAR Method. The growth of the thin films from metal sulfides has been an essential issue in recent years as an alternative way to produce energy and are constantly being sought. It is seeking to study the variation of the physical properties of the manganese sulfide thin films synthesized on three different substrates, such as ITO and FTO glass, from a chemical deposit method called SILAR, where this experiment will be carried out at a temperature of 80 degrees Celsius, and thus identifying the substrate and favorable qualities for a photovoltaic system. It is known that the p-n hinge reductions of the manganese sulfide has a band gap of 3.02 electron volts, which in Figure 1, we can see the region where it is located, which makes this metal sulfide very attractive for energy production. This synthesis was analyzed with the Nicolau reaction mechanism, where reactant sodium sulfide with manganese chloride gives us the formation of the manganese sulfide, which is our thin film. The formation of these products is verified with the analysis of the constants of both dissociation of manganese chloride that gives us the value of 400 based on the concentration of the solutions that we use and of 1600 for the dissociation of the sodium sulfide, and we have the formation constant of manganese sulfide, which is 200, which tells us that it is desired products are formed. The device used for the synthesis of the manganese sulfide thin films was the robot Renovatio 1.2 that can be seen in Figure 4, made by Dr. Antonio del Rio de Santiago from the Autonomous University of Zacatecas, where the thin films were obtained, as you can see in Figure 5. In section I, we can see the glass substrate. In B, we have ITO, and C, we have FTO. All thin films are between 65% and 90% transmittance. With this, we can say that our samples are semi-transparent. These results were obtained after being subjected to a spectroscopic characterization of ultraviolet visible in CHIMADZU UV 300-600I+ from the CIAC and YT Research Center. And by applying the Theok method, we were able to obtain the band gap of each sample, resulting in the glass of having a transmissions of 90% and a band gap of 4.05 eV, as we can see in graph 1. The ITO has a transmittance of 65% and a band gap of 3.45 electron volts, as we can be seen in graph 2. And the FTO has a transmittance of 75% and a band gap of 3.84 electron volts, as we can see in graph 3. And with this, we conclude that the variation of the substrate in the synthesis did alter certain physical parameters, such as transmittance and band gap, having qualities superior to ITO over the others, having a transmittance of 65% and a band gap of 3.45 electron volts.